All right, let's look at this circuit. We had similar things for capacitors. I have a circuit. It's a little more complex than we've seen before, but I just want to find what is the equivalent resistance of this circuit. We're going to pick the smallest component that is either in series or parallel. In this case, it's going to be this branch right here. Notice those are two resistors in series. None of the other resistors are in either series or parallel with in the simplest form, such as these. And so the resistance of those two is just going to be 1 plus 2. I have an EMF there. I have 4 ohms. I have 6 ohms up top. Now I have 3 ohms, and I have 2 ohms on the bottom. And then it goes back. Now I want to find the equivalent resistance of these two, or these 3 rather. And to do that, I say 1 over 6 plus 1 over 3 plus 1 over 2. Was that 1 6 plus 2 6 plus 3 6? 1 plus 2. Wait, that's 1, right? Yeah, so that's just equal to 1 over 1, which equals 1. Then I have a 4 ohm resistor and a 1 ohm resistor, and to find the equivalent of that, I just say 4 plus 1. And so the equivalent resistance is just 5 ohms. All right, now let's ask ourselves some questions. Let's say that I had a 10-volt battery here. 10-volt battery. I can figure out what is the total current. The total current here would equal 2 amps. I equals V over R. That's 10 over 5 equals 2 amps. That means that as I come up through here, I have 2 amps of current. That way, when I come through this circuit, what's our current? I have I1 equal to 2 amps. Likewise, I can calculate V1, which has to be, 8 volts. 2 amps times 4 ohms, IR, is 8 volts. So, then, what is the voltage across this parallel branch? Well, if I have 8 volts across that branch, across that resistor, that means that I have to have 10 volts minus 8 volts equals 2 volts. Because I know that on these two resistors here and here, I have 8 volts, and I have to have 2 volts here. And that 2 volts represents the voltage that's across this whole parallel branch. Now these are all in parallel, so that means that I have 2 volts here, 2 volts here. All right? Now R3 and R4 are a little more complicated, but well, I can go ahead and figure out what is I. So I2 is V over R. That's 2 over 6, or 1/3 amp. I5 is equal to V over R. That's 2 over 2, or 1 amp. So now I want to find the current going through this branch. And I can do that in a couple different ways. One, I know that the equivalent, let's go back down here. I know the equivalent of those two is 3 ohms right here. And I also know that the voltage across the two is 2 volts. So I can find the current through this resistor, which would be the same as the current through these resistors, is V over R, or 2 over 3. 2 volts over 3 ohms. All right, so that means that I have 2/3 of an amp going through that resistor. Through both of those resistors, excuse me. And so I get IR is 2/3 volts and 4/3 volts. Which, by the way, add up to 6/3 volts, which is 2 volts, which is what I know is across these other branches, 2 volts. Another way I can do this is, look, I know that I have 2 amps coming into this parallel branch right here, and it's split up. I get 1/3 amp and 1 amp, so I already have 1 1/3 amps accounted for. So that means I have to have another 2/3 of an amp going through that center circuit. There are lots of different ways you can get to these answers. And as you get practice with them, some of them will become more obvious to you than others. But that's really the key to this, is that you're able to practice. There are some quick test questions here that you should try on your own. And then also you'll see some homework as well. Here's some, you want to find the equivalent resistance and the potential across the resistor R3. Those are great test questions. There's some other just sort of conceptual questions. And we will pause there and soon pick up with another topic.